you know me. I don't need no introduction. You know me, I don't need no introduction and shit.
What's up, everybody? 702 Exotic back at you with another live. What's up with y'all? Man, we got a pretty good topic today. I think it's a pretty underrated topic, for real, inside of the grown community, right? I feel like it's something that is very, very necessary in the growing community, but I feel like it's one of the most under-talked topics that there is, right? In this space. I've been realizing a lot of things inside this growing community. We focus a lot on genetics. We focus a lot on nutrients. We focus a lot on equipment, right? But we do not focus a lot on electrical. That's right. We do not focus a lot on electrical. That's just the bottom line. We just really don't focus a lot on electrical.
All right, we're in the flower room working on this breaker. Checking line voltage. Should be 120. Good, tighten that neutral. Always kill the power before you dig in. Everything's reading clean, lights back on, plant.
And that's my point right there, right? Inside of this space, what we do is we got to be it all. We got to be it all. We got to be, let me spark this up real quick. If you guys are tuning in right now, make sure you hit that like button. Subscribe to the channel if you want to watch another video like this. Make sure you hit that like button, subscribe to the channel if you want to watch another video like this. That's right. Hey, and we're gonna be talking about your grow as well. If you want to go ahead and chime in, we could do a little bit of math, we could do a little bit of things, talking about this topic that we got here today. So that's what we're gonna talk about, right? Oh, look who we got in the house.
Young Gun in the building acting bad tonight.
That's right, Piff. Young Gun's in the building. So let's go ahead and get started, man. We got a long day. We got a long topic. It's pretty long. So let's go ahead and start the show, all right? So how much power does a grow room really use, right? How much, I feel like that's like one of the biggest questions that people get and ask too, right? Like, how much power do you use? How much power do you need? How much power do you consume, right? And I feel like it's a very simple question to answer, right? Well, how many amps are you running, right? And a lot of people, that's what I think that people get hung up on, is the amperage. And wattages and voltages and stuff like that. Along that is very, 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 very dangerous too. Electrical could be very, very dangerous to some. If you know what you're doing, well, you know, it's not as dangerous. So, but my simple grow, we're going to go ahead and take a look here what my simple grow looks like. I mean, 1 second. My simple grow, right? So we got a little 3x3 tent, right? That's what we got. Let me go here. Let me see. I could have swore this was going to be just a little bit easier, but it's not. So just bear with me here. Let me see. This is a 4x4 right here. That is a 4x4. But I have a the same tent here, but it's a 3x3. Sorry, not a 3x3. This is a Sorry, not a 4x4. This is a 3x3. This is a small little 3x3 by AC Infinity, right? So you got yourself a small little tent right there, right? And then we have an inline fan, right? Where is the inline fan here? Let me see. So here we go. That's the inline fan. That's the inline fan right there. And we're going to be calculating this stuff right here. So the AC Infinity inline fan is part of the controller, right? So that there is part of the controller. So you got your fan. The tent doesn't run power, but it's in the fan, right? That's what you're going to get. So my tent is running a fan inside of there. And then it's also running a 100-watt light, which is this one right here. And that's inside my 2x2. That's what I keep inside of a small 2x2. That tent right there is a 3x3, right? That tent is a 3x3. But I have a different light inside of there. I have a different light inside of that 3x3. But just picture the same, but a 2x2, right? Picture the same thing, but a 2x2. Got your inline fan. Then you got your light there. Okay. So we got 100 watts, but I got it around 50% power, right? It's turned down. So I went ahead and checked it with my meter, right? I went ahead and checked it with my meter. Right here. Let's take a look. Oh, that's not it. That's not it either. Let me see 1 second here. That way y'all can see exactly what I'm talking about. So see what I did right here? I went ahead and checked my amperage. How much amperage is leaving outside there, right? So I went ahead and checked how many amps I'm pulling out of there. I check how many amps I'm pulling out of my small little tent. Little 2x2, right? Little inline fan. And then you got your light. Went ahead and checked it with my meter. And I was pulling a total of 0.7 amps. Not even 1 amp. All right? Out of there at the top. So despite what you're running, depending on how you're running everything, it's best just to go inside the line and check it right there. See how many amps you're really pulling. And that's the line. You don't need to have 2-3 wires. You just have to make sure that it is that wire that goes to whatever you're checking, you know, to be able to identify that it is that power that goes to whatever you're wiring up. Now, this is different. Check this out. So I do have, remember, we were talking about a setup where it's a 2x2. So, right. So 2x2 with 100 watt. Now, what happens if you change this light here? If you were to take that light out of the equation and then you enter this Mogobe in here, right? This 300 water, that's what I got inside that 3x3. All right. Now you change up a few little things now. All right. Now you change up a few little things now. So let's take a look at this. That's the 0.7. That's the wire. Now look at that. So we went from 0.7. We went from 0.7 to 3. Almost 3. With that 300 water. You know? So that's how much we're putting on, and that's everything. So that would be the inline fan, the 300 watts, and a few, I think it's got like a few little fans in there and stuff like that, but I tested it at the top right there. I tested it right here at the top, right where we at. Right there. So like that. I tested it just like that. So with that one wire, your little amp meter, you clip it over the wire, and that's how you get your amperage. That way you know what you're running too. You can always touch the wire too to see if it's warm. If that wire gets warm, then you definitely got an issue right there. So that's something to take a look at. I would hook everything up. First, I would do the calculations. The calculations you're gonna have. Let me take these off the screen here. So the calculations that you're gonna have for this is everything. So whatever your wattage is, you're gonna divide that by your amperage, by your voltage. Sorry. So whatever your wattage is, you're going to divide that by your voltage. So if you got 100 watts, which that light was 100 watts, you divide that by 120, right? So you PIF, you got 320 watts, right? You divide that by 120. I can give you that answer too. Let me see. Let me see here. PIF, just hold on 1 second. So you got 3,200. By 120. All right, I'm gonna give you that real quick. So that calculation for that PIF, you are running. Let me see. 1 second. 3,200 watts. Okay, no, it's 320 watts. My bad, bro. Ha. I'm putting you at 3,000 watts. I'm putting you at 3,200 watts, champ. That changed a lot. All right, so you're doing 2.67 amps, PIF. You're doing 2.67. So 2.7 amps. That's how much you drawing for your 320 watt light. Just one. So if you multiply that, you'll know how many you can get on a 20 amp circuit, you know? That way you know you're not overloading your circuits. So that right there is for like a small little grow, right? You're gonna talk about, like, you know, fill in and stuff like that for like fans, inline fans, or whatever you got going on. But that's just pretty much the home grow basics, you know. Just remember, you're gonna be pulling from like the same shared circuits as the kitchen, AC, and TV. You know, so every amp counts at that point. If not, you're just gonna be tripping breakers like I used to back in the day. It's all about keeping it neat, safe, man. You got to keep it all safe, right? And facility power, man, that's a whole different ball game right there. When you talk about big time facility power, so that facility power, you're gonna be running different powers. So you got to know what you got type of, as far as 120. 277 or a 480 volt service, you know, and how many amperage. Do you have a 400 amp? Do you have an 800 amp? You know, there's some that have 1,000 amp breakers, you know, and stuff like that. And you got to make sure that is adequate for that wire and stuff like that. So running EMT, you got to know how to run pipe, right? When we're talking about running pipe, this is what we're talking about right here. So those are contactors, stuff like this. See, you're going to have to learn how to run EMT like this. You're going to have to learn how to wire up stuff, you know. So you're going to have to learn how to, let me see, that's the amps. You're going to have to learn how to, let me see, where's my pipe? I think the pipe is down here. You're going to have to learn how to bend conduit like this, right? This is how you're going to have to learn how to bend conduit. It's a very, very tedious thing. You can see on the left side right there. That was already previous. I didn't do that. I did do the 3 rows that go up and then 90 out. I did that. And those are the circuits that I added. I didn't do the left side right there. That's a whole different electrician that did that. So these are for an electrical space. I mean, for electrical grow space. And as you can see, that's the panel that comes down. That's how it goes up and turns over into where it needs to go. The 90s that go up. And then they go over into a catwalk, and they go down here. So this is where they go down. All those go down. We got boxes that go into other panels. They go into other rooms. And those are the wires that we ended up bringing inside that panel. That's what's actually inside those pipes that we ran. Well, I ran. So all that's inside there. And that's on the other side over there. That goes all the way out there to the very entrance of the actual room itself. So that's what it takes right there to do big major facilities when it comes to power. When you're talking about big major grow rooms, right? That right there is definitely a different ball game when you're talking about big facilities, right? Because in the facilities like that, we're talking about 277, 480 services. Again, you know, all those EMTs got to have 3-phase power in them, right? You know, and you got multiple rooms too. You got this room, and this room. There's about 4 or 5 rooms. So load planning is very, very important. You know, the home grows, you kind of eyeball things, right? Unless you really know what you're doing, then you can go out there and check, you know, like your loads, like I'm doing with my meter here. But the facility, man, that's a whole different ball game, man. You got to really calculate that stuff before you get in there and really, you know, just know that a lot of times you want to ask at least 800 amps for a grow, something like that, you know. That's what you're going to need, you know, because facilities have lots of lighting, right? All of the lighting is on 277, so that's coming out of a different panel. You have 10-ton roof units, you know, and those are on 480, right, on the disconnects. And then at home, you're running off of your regular AC unit or at the mercy of the outside, you know. And then you go to your lights, right? If you're running Gavitas, right, which in most instances they are, right? Each Gavita is probably going to pull about 0.8 amps, right? Each Gavita. So you're looking at, those can add up really, really quick. The dehumidifiers, if you're going to have 4 units, at 7 amps each. Right? 277 volt though. Because if you go 120, then you got to double that to 14. Because remember, you're dividing, so kind of double it. Then you got pumps, controls, receptacles, all that stuff, right? The HVAC, like I said, 10-ton units, 480, 3-out wire, or 3-out RTUs at 28 amps each, right? 28. And you're going to have 2 of those. That's for a major facility, right? Lighting. So if you got 50 lights, 50 fixtures, 50 Gavitas at 0.8 of an amp, that's 40 amps. At 277 though, continuous power, because a continuous load, you got to maximize it at 125%. So that becomes a 50 amp allowance on that, because you can't do 40 on a regular because it's continuous. You gotta remember the NEC is different when it's continuous load. Those lights are gonna continuously be on. All right. So there's not like a regular office where you're gonna go work, go to lunch, and then no, them things run. Branch circuits. The 277, the 20 amps, you know, those are 80 continuous rule if you're gonna branch them. You know, another thing is the circuit, you know, the phases. Phase A, phase B, phase C. Say you got 20 on phase A, 20 on phase B, and 10 on phase C, right? You got 16 amps all the way on A, 16 on B, 8 on C. You know what I mean? That way those balances, when the power leaves, you know, it doesn't heat up things, right? It doesn't heat up things. Because a lot of times when things get heat up, that's a problem. That's a problem when things get heat up, because if they do, man, then you can start coming into fires. Then you got dehumidifiers, right? Dehumidifiers. Example, say we got 7 amp at 277. That's 28 amps right there, right? So at 277 continuous, that's 28 amps. And then the amperage, 14 amps, 2 units, right? On the B phase, 7 amps. And then on the C phase, you got 7 amps. That's how that goes, you know. And then the inline fans, you got 12 of them, 1.2 amps each at 277, total of 14 amps. The pumps, the controllers, and all that, you know, you kind of got to like estimate those. You got to make sure you know how much your pumps is, but we can't do that because it could be all over the place, right? And then, so then you got your transformers, and you got to look at what transformer pulls out of what. That'll tell you what panel is what, right? When you're in a commercial facility, when you step into your first big facility, that's what you got to start learning. Which one is your big power and your low? In electrical, you know, we'll call it high voltage, low voltage. You know, even though it's not low voltage though. So we consider low voltage as 120. High voltage, anything 277, 480 and above. All right, so that is that. So you want to calculate all of that, all of the calculations, right? So on a 400 amp, you know, the highest phase got to be 91 amps. That's on a 400, not a 200. So that gives you an idea on what you're running and stuff like that, right? Gives you an idea. So now let's get into a little bit about breakers. Let's get into a little bit about the breakers, right? So the breakers are these, you know, everybody knows what breakers are. They're just pretty much what feeds the power from the panel, right? See if I have a breaker here. Nope, I don't have a breaker accessible right now. They're all put away. But it's just, everyone knows what a breaker is, right? And that starts at your panel. That's where your panel really leaves the power, right? The power leaves first at the breaker, you know. So, but if you're running 16 lights, you don't want to run it off a 20 amp breaker because you want to stagger them, right? If you don't want to put in too much stuff on the one phase, right? So you want to stagger them. That's what your breakers are for. Your breakers, every other one, it's on a different phase, you know. So now that you know what a breaker is, let's get into the wire sizes. So a wire size here, let me go down to my chart here. A wire size for the breakers is, so if you got a 15 amp breaker, you're allowed to put a 14 gauge wire, right? That allows you to go up to maximum 12 amps. That's for like small fans and stuff like that. Then you got a 20 amp breaker. A 20 amp breaker, you can only put a number 12 wire. And the maximum of amperage, the load that you can put on that is 16 amps. And remember, the way you can check your amperage is you got to stick the wire through this here. So you can get a meter, you know, anything that has one of these holes at the top, that's to check your amperage. So you don't check your amperage with your probes. You check your I have my probes here, but I wasn't checking voltage because everything works. I was checking amperage. And that's what we do a lot in electrical and in grows, because you're adding stuff and you want to keep knowing what your amperage is. It's always good to write down the amperage somewhere, right? If you need to write down the amperage somewhere. So we have a 30 amp can go up to number 10 wire, maximum 24. You know, these are dehumidifiers and etc. The 20 amps are more for lighting, right? You don't want to run more than 20 amps for lighting. So you don't want to say, okay, I have 150 lights, it's 200 amps, so I'm gonna run a big wire. No, you really want to stick with 277 20 amps circuits for lighting. And you have 40 amps. That's number 8 wire. The maximum you can go is 32, and that's larger LED banks, like where you can put a bunch of LEDs into one thing, right? That's a LED bank. So that's 40 amps, and then 50 amps you can do a number 6 wire, maximum 40 amps with your probe meter, and yeah. So 50 amps, number 6 wire. Those are sub panels, right? Say you need power along in another place, but you don't want to bring a bunch of small circuits. You can bring a lot of big circuits over there, put separate panels over there, and then work off that. Then you can wire up other stuff. And let me see. So that's 50 amp there. 60 amp, that's number 6 wire. And that's, like I said, small panels, that's 60 amp. 80 amp, right? That's number 4 wire. Maximum of 64 amps. And that's like feeding a lighting panel. So like if you're gonna feed a whole lighting panel, you want to get a lighting panel, you'll bring in 100 amps. 125, that's like a secondary distribution panel. And then you got 150 amps, that's 1/0, 120 amps max. That's like multi-room grow room facility feeds right there. And then you have 200 amps, that's 2/0 wire, 160 max. That's a main service. And then you have a 400 amp, that's a main service too. That's the full facility, you know, and that's 500, 600 MCM. So that's the biggest wire that they make there. Well, actually, no, I think 700s are. 750s, my bad. 750s is the biggest they make, but that's rare. That's like 750s, they put those like in data centers. So that's another thing. Breakers and GFIs. Let's get into GFIs too. You're gonna need GFIs everywhere you have water, right? Because water, electricity don't mix. You're gonna have water in a lot of these places, but you can't GFI like lights and stuff like that, right? Mike Flynn, I see you, champ. But yeah, man. So you don't want to have a bunch of water inside your electrical like that. As far as just regular outlets. No, you want to have a GFI there, and that GFI right there is gonna piggyback off the rest of them. So you're gonna have piggyback receptacles. You can have one GFI, and everything after that could be GFI through that one GFI. But again, you got to remember, do not plug in too much stuff. So you got to check how much amperage is going through that wire, because it's all about amperage. The voltage is stay the same. You know, you want to have voltage from point A to point B the same. So if you got 120 at the breaker, you want to have 120 at the wherever you're at, and so on and so forth, right? The voltage remains the same. It travels at the speed of light. It does not drop. What goes up is the number of amps, right? Because that's what you're drawing through that wire. So that's one thing. Grounding is very important too. In when you're talking about anything, save your life, right? It could definitely save your life, but grounding, a lot of people don't really need to know about that, because that's done while the initial installation is done, right? So majority of the time when you get to a building, it's called the shell, right? So the building is called the shell. So and a lot of times, like, it'll be different contractors working on the shell and then the TI, right? So the TI will be whatever person or place is going to do business inside the building, and then you have the shell. That's a lot of times is the owner of the building itself, you know. So the shell a lot of times already comes very grounded, because it's built when the ground up. So it's built from the ground up. So the shell is built from the ground up. A lot of times those have to be inspected before they even have a tenant in there. So that's you don't really need to know about grounding. Just know that when you're installing new stuff, if you see the ground, use it. You know, just ground it to something. If you're in metal, especially, like if you're in metal, you're in metal, ground it. Put a ground to it somewhere in the box. Make sure you got your ground screws. That goes to a light or whatever. Make sure you're always grounded. Grounding is very important. Can save your life. But like I said, not really too much to look at there, because, you know, most of the times the buildings are already grounded when they come built shelled up. So yep, let's go ahead and Now that we turned off the power, I'm going to tell one of my workers to go turn the power back on. So he's going to go do that.
Let's light it up.
He's doing that now. That's right. So he went to go turn on the power in that building. So he's over there. We're powered up over there on that whole side. And that's it, man. That's it. And I'm gonna put my power back on. Let me go throw my power back on.
23 engaged. Voltage holding at 408. Panel 3 is clear. Moving to feed 4.
All right, moving to feed 4. So we're already rocked and loaded, man. We in the facility. Everything is lit up, right? So the panels are looking beautiful. That's how we wired them up right here. As you guys can see, everything looks nice and neat, right? All your wires are in phases. So you have brown, orange, yellow, right? That's a phase. That one will utilize a neutral. Brown, orange, yellow, utilize a neutral. Brown, orange, yellow, utilize a neutral. And that brown, orange, yellow is what you call a boat. I don't know why. I didn't invent this phrase, or like I say, it was here before me, and it'll be here after I'm gone. But a brown, orange, and yellow, those are called one boat. It's called the boat. So you have 1, 2, 3, 4, 5 boats there, right? And you see everything is labeled very nice and neat. So when you take off the panel cover, it's called the dead front. And they call that a dead front because somebody died. So they had to call it a dead front. They died taking the front off. So dead front. I didn't make that word either. It was here before me, and it'll be here after me too as well. So you got your grounds right there, your main ground coming in. And it may look like a lot. It may look like it was very difficult. But if you see, I like to keep my wires nice and neat, all at the same lengths. So stuff can look very nice and neat, right? When you come back in, or the next electrician comes back in, it's not a rat's nest, you know. You don't you don't have to troubleshoot this thing too much, you know. And that's some of the pipe work we ran there. That's just some of it. Yeah. So let's see. So all those are balanced, right? We have balanced loads all there, and that was all for lighting there. Everything is labeled, every breaker. You'll thank yourself later, I promise, man. Because when you go down and you have to do more work, you know, you always want to go make sure that you're turning off the right breaker. Say you got to go work on a breaker, and you come back, you'll have a nightmare trying to find it, and that's important.
Amps. Clamp meter reads 23.5 amps. Multimeter shows 479 volts solid. Contactor terminal snug. Label made and set. Cover on. Power up.
And that's right. You got to label everything, because that's something that bit me in the butt before, you know. You go back there and it's not labeled correctly. All right, so let's move on. Bad extension cords, right? We're going to step it back to a home grower. I hope you're not running extension cords in a commercial facility, because that right there, you'll need some better funding. I would say if you're at home and you're running extension cords, because sometimes you have to, those cheap orange Home Depot cords, man, those are for leaf blowers, man, not grow lights. And you'll wonder why you're tripping the breaker. A lot of times it might not be just because of your light. It could be because you're using a cheap cord. Because inside that cord, you also have gauges of wire, right? You can buy those in gauges. So you got to make sure that you're buying a gauge that's at least a 12 gauge, wire inside there, because you know those cheap ones might be 14. It could be for what do you call Christmas lights? You know, Christmas lights pull damn near nothing compared to your Gavita. You know, when you got 2-3 of them inside there with your AC unit, 14,000 BTU little Soleus Tech. You know what I mean? That'll definitely trip some breakers. So you want to make sure you're getting, if you have to put one over here and one that goes all the way to the living room in a separate circuit, that's what you got to do, right? Until you get your power right. But they overheat fast, man, under constant load, that's for sure. And if you have an extension, then you got to, like, say you extend another one to another one, then you got to account for voltage drop too. Because the best way to do it is just hardwire. Figure out how you can get a brand new wire from your panel to over there. Like I say, get a 50 amp, right? A 50, 60 amp, maybe 50 from your actual breaker box to your garage with an additional breaker box there. And then now it gives you a free space, right? You can put it on a nice little on a plywood, right? You can make yourself a panel, like a panel board, right? And then you can put your panel in the middle, and you can have all your nice wires or whatever you have pipe coming in, right? But off of your 50 amp from your actual breaker box at home, right? So now if you don't feel safe doing it, then hire an electrician. Just say, hey, look, man, you ain't got to say what it's for, nothing like that. You just say, I need you to run me a 50 amp, everything up to code, NEC, right? A 50 amp sub panel to my garage. Once you do that, then you have access to be able to go turn that off through the breaker. Then your sub panel will all die, right? What that will allow you to do is you have your whole sub panel at another location. You have your meter, and you can always be testing the wire that comes inside that powers up everything in there. And that right there would give you a great idea how many amperage you're pulling through your whole system, right? So when you do that, you're going to be a lot safer. You're going to know what's going on, because you won't have a bunch of wires and extension cords going through your whole house. You just have that going straight to wherever your source is at, and then it goes, Now, it's very important to note, you do not want to have your panel like where your irrigation equipment is at either, like not where you're mixing water and stuff like that. But it won't damage anything if you keep it inside of a room where there is humidity and stuff like that. Because I've seen plenty of grows have electrical inside and, work forever. So, yes, sir. And that's pretty much it on that. Talking about those, and remember, just the 80% rule. You never want to be 80% maxed out, because remember, we're doing constant, right? And you remember the basic math for formulas too as well. You want to remember this. It's very simple too as well. You got your wattage, right, divided by your volts, gives you your amperage. Very simple, right? Very simple. Wiring setup, make sure everything is nice and neat. Always nice and neat, right? Even if it takes you an extra second, an extra wire. I always leave my wires a little bit longer. As you can see, before I wired everything up. Let me see if I go to the right one. Nope. Right there. You see how my wires really only had to go to those breakers right there. But you see how I left them to the ground. And the reason why I do that is because I want to have enough length to do things that I want to do them with. I hear a lot of electricians, working on their stuff, and they're like, well, I only need it to right there. And you wonder why they struggle later on. Get enough length, make it look good, right? Want to make it look like this at the very end. Let me see here. I'll take that off. Where we at? Nope. You want to make it look like that at the very end. So that has to turn into that, And that gives you your room. So even if you're clipping about 6 inches, 6, 7 inches, You know, it's no problem with that. At the end, you got your little scraps, put them in your bucket. You know, but your work speaks for itself, right? Your work will always be good. You don't hinder your work because you want to be cheap. So, something to keep in mind there, boys, when you're wiring up your electrical. And, all right, moving on down. Contactors. What are contactors? Contactors are these things right here. Now, what is that about? Those contactors there, you see a whole bunch of wires coming in and out, right? They just come in and out. But the beauty of a contactor is that you can wire up pretty much all these wires here. I keep going to that one. Let me see. You can wire up all these wires. See, these are breakers that have on and off, on and off, on and off. But you physically have to be there to turn each one of these breakers on and off. You have to be there. So how can I get all these wires to turn on for me at one time when I want them to turn on, right? If I want them to turn on at any given time, say I want them to turn on at this time, all of them, all those wires coming from a panel. Well, you can hook them up to contactors. You can hook them up to these contactors here. Those contactors there will allow you to work in between. Let me play that one more time for you so you can see how it works. Wires coming in, wires leaving. And that right there turns all the automation on. You see, that's how the automation happens, boys. That's how the automation happens. Just like that. Through these contactors. So we'll essentially take all those wires that I showed you, we'll take them over and wire them up to contactors. And once they're inside of those contactors there, then I'm allowed to control them because every contactor has a switch, right? And I can have switches to be able to control anything I want. Say I have a contactor here and these bank of contactors, I want this only to control the lights. So I can wire up all these contactors together, right? Daisy chain them. And that line that leaves will be on a switch, right? That switch right here is controlled by a controller that you can go on a computer, Wi-Fi, anywhere in the world and say, I want those to turn on. Hit that switch. Your grow room lights will turn on. Now that you know that same bank of switch right there, right, is controlled, daisy chained by one switch. Contactors, all those bank of contactors, daisy chain controlled by one switch. Now you can have a set of contactors on the bottom here. Now all of these contactors here can control your humidifiers. Again, they daisy chain. Say you have 6 humidifiers, 2 in here in this room, 2 in that room. You can daisy chain those 2, put a switch to one controller. You can put daisy chain the other 2, daisy chain to another controller. Now that controller can modify and say we have grow room 1 and grow room 2 humidifier. And those are always checking the humidity in there. Only you have a drop sensor inside of your grow room. And every time your humidity goes up, that switch in your computer then triggers that contactor. That contactor would then turn on your humidifier. And that's your humidifier over there kick on inside that room. Now you have this other one that doesn't kick on because you have it on a different switch. So now you can automate your humidifiers. Now you have your lights at the top that are on a switches, and you can divide those switches into different switches. So you have all your lights at the top, humidifiers in the middle, and then you can have stuff like fans, irrigation, etc., etc., etc. And that's what contactors do. That's what these here do. Master controller there, that'll tell I need this to do this, I need that to do that, and all those are on their own contactors. So if you're ever in a room that has, you'll always hear the contactors doing their own thing. You'll be in there just chilling, working on things, and you'll just randomly hear click, 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 and that's the automation itself. Checking on VPDs. Making sure the VPDs are on point there, and that's how you work all these things here. And those are contactors there. Contactors are very easy to wire when you have a fresh, clean slate. Say you have a contactor box, you have everything labeled coming in, and you're actually the one doing it, because you're just essentially grabbing your 3 wires coming in, and the ones that are coming from the panel, and you just come, and then they meet inside the contactor, and then again, so on and so forth. So you just grab a bunch of them, and then again you'll just make like this beautiful painting. I've done many of them, of those contactors boxes. But what is hard, I'm gonna tell you what is hard, when you get there and they're already wired, and you have to figure out which contactor is which and which controls what, especially when stuff is not labeled. So now you have to really know what you're doing. And then the thing is, you can't just go in there and testing contactors, because remember, you don't know what these contactors are doing. So a lot of times a contactor could be dead, and you're like, oh, I have a bad contactor, or I have bad this. But the system could purposely tell that contactor to be off, because remember, the humidifier could be on a contactor. So if the humidity is within range, then those contacts ain't going to be contacted. They're not going to be, because that's all it's doing is making the contact, Wires come in, wires leave, they make the contact. And that trigger wire is the switch, and that's where you can put it on a random switch too. You can put it on a light switch. You can put contactors on anything, because the contactor runs on 120 volts. They have different type of contactors. They have 12 volt, 120 volts, but no high voltage contactors really. They're the voltage on the contactor switch, because you have a little switch part that ties into it. You know what I mean? You got to bring your power to that contactor, which will activate whatever you're strapping onto. You know what I mean? So they're pretty simple. It's like, but they are hard to troubleshoot if stuff is just not labeled on where it's coming from. So you'll need a skilled electrician to be able to work on those things right there. And guys, I honestly think I covered everything. I honestly think I really did cover everything from the home to major facilities and automation. And I think that's pretty much it. I think that's really pretty much it. I like working on electrical, and I like it. That's something I do enjoy working on, electrical, and especially in facilities where plants are involved, right? Because it's like the best of both worlds in my world, because I get to do what I love, and I get to do what I love. And working with those two things is just a blessing, right? I feel like I started electrical as my first trade, and I just kept it going. That's all I've ever done besides growing and trapping and being in the streets a lot of the times. So it's like half and half, right? I have half full experience in electrical, but I always did electrical even though I wasn't working for someone. Like even if I was like trapping or whatever in my trapping days, I still would do like side jobs. I would never turn down no money. It's crazy because like people would like see me come through with a pound and then see me with a tool belt on and be like, what the, you know what I mean? And yeah, so I never turned down money. But yeah, man, that's something that I know now, I can work on in the electrical space, like as far as weed comes. Like I don't have to sell weed no more. I don't have to, you know, grow weed no more, like for the masses, but I could be involved in it, right? I could be powering up these facilities, working with people that need help in the electrical space. Because I feel like, again, it's a very underrated topic when it comes to our niche, right? We talk about a lot about everything else, but we don't emphasize electrical, how fast you can burn a house down, how many houses been burned down through growing, right? Because they're just tripping the breaker. You see a lot of times that people hold down breakers, like, you know, not them physically, but they'll put something there for the breaker not to trip. And, you know, if you're tripping a breaker, let me close with this. You know, it's tripping for a reason. It's doing its job. Very rarely you're going to have a breaker that just doesn't hold. But when you keep tripping the breaker, you have a spring inside that does get weaker and weaker and weaker and weaker and weaker. Replacing the breaker, but if it keeps tripping, you have a real serious problem there. It's something you need to fix. If you have any more questions on electrical, feel free. You see the number up there. You can hit me up anytime. And I feel like I can bring a lot of value in this space when it comes to electrical. So if you guys have any questions, troubleshoots, or problems, let me know. I'm only a call away, y'all. Peace. To the next one, this is your man, 702 Exotic. And yeah.
Young nigga help keep a digital skill in the escape.